If you haven't turned this in yet, you can still turn it in for half credit, right? I think I've got most of them. So even after I go over it. So make sure you check your answers so you get the right answer so you can go back and study for the test for this. Number one, it says determine the following compounds, if the following compounds are likely to have ionic or covalent bonds. This is simple enough to identify ionic compounds or covalent molecules. All you have to do is look for a metal. If there's a metal in it, it's what?
Ionic.
It's ionic, okay? So the first one, magnesium oxide. Does magnesium oxide have a metal in it?
Yes.
Yeah, magnesium is a metal, so this is ionic. What about strontium chloride? Is strontium a metal? Yeah, so it's ionic. What about ozone?
It's covalent.
There's no metal, right? Oxygen is a non-metal, so that's covalent. And then methanol. Now, I always get people confused with H. We treat H as a non-metal. Okay, even though it's on the left-hand side of the periodic table, it has one valence electron. That's why it's in group 1. Okay, but it really acts like a non-metal. Okay, and to tell you the truth, when you get into chemistry, you're going to see it kind of acts like both, is what it does. All right, but for us, we're going to consider it a non-metal. So, and really, if there's a metal in it, the metal will be the first thing listed. All right, so the C, if you look at the C is not a metal, so this is also covalent. Yes?
What I tried doing is I tried looking at like all the elements and like seeing their valence electrons and try to do whatever, and then I feel like, oh shoot, I can't do this, and I was missing something, and I was really mad. And then I realized at the very beginning, it's like, oh shoot, if you just got like one metal in there.
Right,
It's like,
that's all you have to do. Just look for a metal. If there's a metal in it, it's ionic. So let me erase that and let's talk about 4. 4 says explain why electrons are shared equally in oxygen, but not in carbon monoxide. Let me move this down a little bit, and I'll write the answer over here. So number 4, in O2, both oxygens want the electrons equal. Okay, because they're the same element. All right, they've got the same what we call electron affinity. Okay, need for those 2 electrons to share. But in CO, the O is closer to 8 and needs, maybe I shouldn't say needs, I'm going to say wants. And wants the electrons more. Now, it's a little bit more complicated than that, okay? Especially for substances in the same group, okay? As a matter of fact, I think it is, I can't remember exactly, but the further down the group is, the greater the electron affinity, the more they want the electrons, okay? But I'm not sure, I'd have to look that up. But that's all we're going to use for now. The closer it is to being in group 18, the more they want the electrons. Number 5, predict whether a silver coin can conduct electricity. So I'm just going to say silver is a metal, so yes, it can conduct electricity. And what kind of bonds does silver have? Metallic. Remember, a metallic bond is just metals being held together with free electrons. That's why electron flows through, or electricity flows through metals. And then number 7, does dinitrogen tetroxide N2O4 have covalent or ionic bonds? Which one is it?
Covalent.
Covalent. Oops. How do you know?
Because there are no metals.
Okay. N and O are non-metals. Okay, both N and O are non-metals. Any questions about that? Okay, so I'm going to erase that and let's talk about the worksheets. Again, all the worksheets we do you can use on the tests or you can use on quizzes, so I'd suggest that you make sure you get the right answers on them.
Can I give you the form for baseball now?
Give it to me at the end.
Okay.
In the So let's start on this side here. And I usually won't go over all of them in the honors class, but I'll go over all of them today so you can make sure that you get them all correct, okay? So we'll go over them real quick. Number one, it says, how many electrons will atom A lose to atom B? Well, atom A has 2 valence electrons. So they already gave it away and said it's going to lose it, but it's easier to lose 2 than it is to gain 6, right? So that's why it loses 2. So the answer here is going to be 2. Number 2, what kind of chemical bond will be formed? Well, we can't tell if it's a metal or a non-metal, but we can tell that we're gaining and losing electrons. So what type of bond is it?
Ionic.
So it has to be ionic. They're not sharing electrons.
no.
It's just giving these 2 electrons over. All right?
What's
So
the difference? The
ionic.
other one has to give.
They have to
electrons
share.
too.
So what did you say?
They both have to give electrons to share.
Okay, no, to share, they both have them equally. Okay? But in ionic, these electrons are just given to atom B. And so now atom A has a full outer shell because the shell inside of the one with the 2 in it is full. And this one has a full outer shell because the outer shell has 2 more and it gives it 8. So they're not sharing electrons, it's just giving away its electrons. And really, it's more complicated than that because what happens in an ionic bond, which we're going to get to here in a second, is A ends up with a charge and B ends up with a charge, and they come together because of their charges, which is why we end up with the name ionic bond. Okay, it's ions coming together and bonding. Okay? Yes?
So if an atom has like 4 in their outer shell and the other one has 4, is that when it would create?
Well, they really what would happen there is probably sharing of electrons, if that was the case.
Uh-huh.
Yeah. Carbon, which I'm not really going to get into this here, but there's a whole area of chemistry devoted to just carbon compounds, which is called organic chemistry. Okay, because of the 4 outer shell electrons, it has a whole bunch of electrons that it can share. So carbon has a tendency to not necessarily form very many ionic compounds. It has a greater tendency to just share those electrons with other nonmetals and form carbon compounds or organic compounds. So number 3, it says if atom A gives up electrons to atom B, what will be the electrical charge? Well, it's giving up negative charges, so what's its overall charge going to be?
Positive.
Positive. So if it gives up 2 negative charges, it's now going to have 2 more protons and electrons, and the charge of atom A is going to be +2. Does that make sense why? Everybody gets confused and thinks, well, it's losing electrons, so it should be -2 because it lost them. It's not about gaining or losing, it's about what the charge is. Okay? So it's going to be +2. So we're going to put down here +2. Then on number 4, if atom B gains electrons from atom A, what will be the charge?
Negative.
-2, because it's gaining electrons. So I'm going to put a -2 up here so we remember why 2 more electrons than protons.
So
That's why it has a -2 charge.
I'm confused on. So explain how you figure out if it's positive or negative.
Okay, so if we count, it says there's 12 protons here.
Yeah.
So if we get rid of these 2,
I get it.
Uh huh.
you now have, so I'm not going to count these 2, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You now have 10 electrons and 12 protons. So you have 2 more protons, 2 more
okay.
positive charges
So
than negative
if the-
charges.
If the protons are greater than the electrons,
It's
then
positive.
It's positive.
Yep.
So
Got it.
whenever an atom is giving up electrons, it goes to the outer shell.
Yeah, when these 2 are given up, it goes to this one's outer shell.
And then if B.
And let's talk about why it goes to the outer shell, because the inner shells are full.
Yeah.
So that's why it has to go to the outer shell. Okay, because we always fill up from the inside out. Now, again, it's a little bit more complicated than that. But that's what we're going to say for now. So they have to go to the outer shell because that's the only place they can hold them. Does that make sense?
Yeah.
Okay. So what are we on? 5. What is an atom with an electrical charge called? It's an ion. Remember, if you have different numbers of electrons, it's ions. An atom with the same element with different number of electrons is an ion. Atom with the same element with different number of neutrons is called an isotope, both I words. And you can't change the number of protons. You can't have atoms with the same element with different numbers of protons because it becomes a different atom. So this is called an ion on number 6, or number 5. Then on number 6, if atom A and atom B form a compound, what will the total charge of the compound be?
Neutral.
Yeah, so a +2 and a -2 come together, and math tells us +2 plus -2 is 0. So that's neutral for us. So 0, +2, and -2. I'm just going to say cancel. Does that make sense? They cancel each other out. And every ionic compound that we talk about in here in the end should be neutral. If it's not neutral, it's not balanced. It's not going to be the way that it forms. All right? So as we go through this chapter, make sure that you understand that it has to be neutral. Now, what that means is this. Let's say that for some reason we had, this was +2, but this over here was -1. So how many of these atoms do we have to balance out the +2? 2 of them, right? So that's how we get things like CaF2. Because you have to have 2 F's because of the charge of the F to cancel out the +2 charge of the Ca. Okay? That's why it ends up like that. All right?
Can't totally understand number 2.
Number 2, what kind of chemical bond will be formed between atom A and atom B? Okay, so we've got 2 types of chemical bonds. Okay? One involves sharing electrons. One involves opposite charges. Okay? Or giving up electrons. So, if electrons are going to be shared, then we're going to have to have a number that's closer to 8 to share. Because what's going to happen here is if these 2 are being shared, this atom wants these electrons a lot more than this atom over here. So it's not going to share them, it's just going to take them.
Yeah.
So that's why it forms an ionic bond. Because this, and I know what we talked about earlier was, an easy way to tell if something's ionic or covalent is if it's a metal. Well, is this a metal? It has 2 valence electrons.
Yeah.
2 valence electrons are right here in group 2. Everything in group 2 is a metal because it's on the left-hand side of the stair-step line. So I think what your problem that you're having is your understanding of sharing.
Yeah.
Okay? So sharing would mean both of them get them.
Yeah.
Both of them get to use them equally. That's not what's happening here. These 2 are just being given up. So if we have electrons being lost or gained, it's ionic. If they're sharing them equally, it's covalent. So let me give an example. Let's say we've got chlorine. Okay, let's draw a dot diagram. So chlorine is in group 17. So how many valence electrons does it have? 7.
7. Yeah.
Right? You drop the 1. So 1, 2, 3, 4, 5, 6, 7. And let's say it's bonded to another chlorine. So the other chlorine has 1, 2, 3, 4, 5, 6, 7. So they each need 1. So what they're going to do is they're going to share this 1 electron. So now if you count, this chlorine has 1, 2, 3, 4, 5, 6, 7, 8. Right? This one has 1, 2, 3, 4, 5, 6, 7, 8. It's not giving up the electrons. They're going to share that one equally between the 2 of them. All right?
So if they both need an equal amount of electrons to fill their most outer shell,
Well, not necessarily an equal amount.
well.
But if they're both close to being
both,
full,
yeah.
it's probably going to be covalent. Yes?
Okay, so how exactly would that work though? Because I thought that you had to like share 2 electrons. So like, wouldn't you need 2 more chlorine atoms?
No, because this 1 electron, and we're getting a little bit more complicated than I wanted to get here. Okay? But this 1 electron, basically they're going to come together so that they can have overlapping orbitals. And so that 1 electron can be used for both of them. Okay?
Makes sense.
So let's talk about this table at the bottom, which we already gave you one answer to. We said the smallest particles here are ions, smallest particle here are molecules. So how are they formed? Ionic is, I'm going to say electrons are gained or lost, and opposite charges attract. That's how ionic compounds are formed. Covalent, electrons are being shared. So this is ion, this is molecule. Then usual state, ionic compounds normally found in solids. Covalent are liquid or gas. Okay? That's not always the way it is, but normally that's what it is. So let's flip it over and talk about the back. And we should be able to go through this pretty quick. Number one, force that holds together the atoms in a compound. It's called a chemical bond. Number two, an atom that has an electrical charge is an ion. Number and sign written by the symbol of an ion to indicate its charge. That's a superscript, right? Here's what we mean by superscript, Mg plus 2. That's a superscript because it's above and smaller, which you have a button. I mean, if you use like Microsoft Word or something, there's a button to superscript things.
So what's a subscript?
A subscript would be like this, H2O. That 2 right there is a subscript, okay?
So a subscript says how many atoms there are of
In a
certain
compound,
element.
yeah. Yeah, but it's always written after the element. So there's 2 hydrogens, all right? Bond that forms between atoms that share electrons, that's covalent. In the system, or sorry, in the symbol Na plus, the plus sign is a superscript. A chlorine ion, Cl minus, has a negative charge, that's what the minus means. And if you wrote Na plus 1, that's not wrong. I'll a lot of times do that, I'll put the plus 1 on there. Because it looks funny with just a plus sign or a minus sign, or Cl minus 1, that's fine, okay? I won't count off for that. The compound NaCl is an example of an ionic compound. There's a couple reasons we know that. One, Na is a metal, right? The other reason we know that is because there's charges, opposite charges being attracted here. Number 8, when Na plus and Cl minus unite to form sodium chloride, the compound that forms is neutral. You've got a plus 1 and a minus 1 coming together to form a charge of 0. Neutral particles formed as a result of the sharing of electrons are called molecules. So anything that's covalently bonded is called a molecule. I usually call anything that's ionically bonded